Let's graph an inequality. So one way I could graph this is to solve for y and graph the slope on the y-intercept. Another way I could do this is by looking at intercepts. So it kind of depends on what you want to do. I think I'll do this one by moving it into slope-intercept form first. So I'm going to subtract 2x from both sides. And the reason I did this is because I wanted to remind you, if I want to get y by itself, I have to divide by a negative. And when you have an inequality, you have to reverse the sign. So when I divide that by a negative, it becomes positive 2x and negative 4. So if I graph this one, I'm going to go down to negative 4 for the y-intercept, and then I'm going to go up 2 over 1, because that's the slope. Now I have to decide on this one if I want to put a solid line or a dashed line. I'm not including the points that are on this equation. An inclusion would be one that had a bar under it. So this one is not included, so it's going to be a dashed line. And then I have to determine if I'm going to shade the points on the top or the bottom. Some teachers teach just pick a point and test it. So let's actually pick a point. Let's pick the point 0, 0 and test it and see if it works. If I have 0, subtract 0, I get 0. Is 0 greater than 4? No. So that means the point 0, 0 doesn't work. So the shading should be on the bottom. The other way I think about this is the line y equals 2x minus 4. I want to think about the y values that are less than this line. Well, the y values that are smaller would be all the ones down here, so the shading would be on the bottom. If I had an equation that was y greater than something, and my line looked like this, y is bigger than this line, I would shade on the top. So you can either pick a test point, or you can look at where y is in order to decide where your shading should go.